London dispersion forces. Look at the separation dependency. The energy is dependent on 1 over r to the 6th. So if you have a certain force at distance of separation x, you double that distance, its force goes down by 2 to the 6th. What's that? 2, 4, 8, 16, 32, 64. It'd be 1/64th as strong just by doubling the distance. So this truly only works in the closest contact situation. These are induced dipoles. We'll talk about that in a second. They're super weak, sometimes less than a kilojoule per mole. So why are we talking about them if they're so super weak? Turns out that a lot of macromolecules, a lot of proteins are very densely packed, where you have atoms literally sitting, touching each other practically. This works in a neutral molecule because sometimes there are unsymmetric distributions of the electrons in the orbital around the nucleus. So we consider a neutral molecule, let's say 6 protons, 6 electrons. The electrons should be kind of evenly spaced around it. But sometimes you might find like 4 of the electrons on this side and 2 on this side. So for a brief instant, there is asymmetry there. There'll be a positive side and a negative side, at least partially positive, partially negative. And that's what we're talking about here with these induced dipole